Welcome to our class on October 31. And as exams are very close by, I think it's a good time to begin to review, to give you a preview of the tests and exams. Several code fragments have been given to you during the term around domains and regions. Apparently, some of you do not know the value of visualization and the need to practice and creating these visual aids. I gave you code directly so that you'll be able to use them, so that you're not starting from scratch and complain that you don't know how to program. I felt by copying my programming, you might be able to start to learn to program well. We've had one tutorial only in Mathematica, but apparently many people have not taken this seriously. Christian Ihega, one of your members, had this question for me last week. Sir, do I need to draw the curve before getting my domain? That question spoiled my weekend. I started thinking, what is the question Christian is asking? What is he really asking? Is it that he has gotten his domain without drawing a curve? Or he doesn't want to, he wants to find a way to cram a technique to just get the domain by one formula? Or what? Does it mean that he has not been practicing all the things we've been showing? I sort of sympathize with Christian because I still remember, even though it's long ago, when I was in high, there was no formula there. You had to be, it was a combination of art and science, and just to get a sketch of a curve. Unfortunately for me, that was the most important part of the calculus, to be able to create a visual aid of what you are really dealing with. If you have a function y is equal to x squared, and you do not even have any idea of how it looks, what it looks like, but you can differentiate it, you can integrate it, that means that you have no clue as to what you are really doing, and you cannot relate that to real life. So the most important thing about your calculus is the graphics. If you do not understand how the the algebraic equations and the calculus you are handling actually correlate with physical reality through a graph, then you are not learning much. So you are not going to progress far, because you can only do well when something can be done by cramming. You do not have depth of understanding. So, Christian, I hope you still have enough time to mend your ways and go and take the graphics seriously. And it turns out that if you don't, you are going to pay again and again, because I will show you a sampling, maybe about 20 questions of about out of the 120 that I've just added to the database. The office will get them ready on time, but they are already there and they will be on time for your tests and exams. So a lot of this really tests your understanding of domains. You will see as we go along why that is important. For instance, take a look at this. I told you to go and draw the other octants. Using, in this particular case, I have the original graph, the original code I gave you drew the first octant of a sphere. Now, here I have the floor that will give us the third octant up and the third octant bottom. But I just decided to do here just the flat surface. So that shows you, and that is important because when I am setting your questions, I want to be sure that the answers are correct. And the way I check my answers is by graphics. If the graphics are right, I know that the answers are correct. If the graphics are not right, I know the answers are wrong. So the graphics are useful in very many ways. It helps you to remember, it helps to tell you you're on the right track or you're on the wrong track, and you can easily check and correct your errors very quickly. So the graphics are really, really important. It is quite possible you can do without them, but I can't do without them personally. So if you are so brilliant that you can do your calculus without graphics, very good for you. But I'm going to ask you some graphical questions here. Christian Kega certainly has not been practicing with the code, and it's not alone. So it's just one. He hasn't been practicing with the code the way I asked you to do. I kept asking you, practice with the code, practice with the code, practice with the code. That is the only way you can ask the question of the necessity of graphics to get the domain. Indeed, it is theoretically possible to find your domains without graphics, as Christian has suggested. A genius could easily do that. Most of us ordinary mortals, however, require graphical cues to visualize and correctly find domains. For example, another example last lecture is this closed path. You see, you remember this closed path last lecture where you have a curve y is equal to x, followed by another one which is x cubed is equal to y squared. That is this closed path. You can go along the closed path. You can do a line integral, or you can do an area integral. Stokes' theorem shows that the two must be the same. But now, suppose you want to do the area integral. You can do it by first of all integrating along x-axis before you go along y-axis. If you go through the x-axis first, you will see that along that your path, this orange curve comes before the blue curve if you are starting with the x first. But if you are starting with the y first, as you are going up, you meet this y is equal to x sketch before you meet this. So that is the reason why it appears that this thing turns upside down when you are equating this. And it is quite possible you can get this without graphics, but I do not know an easier way to be able to get this very clearly apart from using graphics. Try to get the domain without graphics, you are likely to get the wrong answer. You can see our answers are always right because of the graphics there. So that is something I will, this is just one example. Virtually all simple things that you do when you are trying to get domains might benefit from a sketch. A rough sketch doesn't have to be an accurate sketch. A rough sketch will be good enough. But doing nothing and just trying to imagine it code is not necessarily the wisest thing to do. So my answer to Christian is that yes, you do not have to have graphics to do your domains, but graphics can greatly assist you to get the domains correctly. Are there any questions on this before I move on to the other things that I have prepared for this day? If you have any questions, let me have it in the chat about this graphics issue that I've just discussed. I'm waiting for 1 minute in the chat room and see if there's anything coming that I can address before I move on. Okay, nobody has any question. So I hope that is understood and I can move on. Modern engineering practice is mainly through the use of software. Most of the things long gone are the days where engineers use four-figure tables, slide rule, and some other things. Most of the things that you do now are by computations using computer, finite element analysis, graphics, simulations, animation, etc. Understanding the underlying math cannot be outsourced. Software can reduce drudgery and monotonous work, but it cannot replace the analyst. So graphics aid your understanding of the underlying math. In my undergraduate days, ability to perform difficult computations was a sign of excellence. In fact, you know that a student is good if he can do heavy differential equations, heavy simultaneous calculus, integration, differentiation, all those things. Today, there's a transition of requirements. The center of gravity is shifted towards specification of a problem so the computer can solve it. So the problem, the essence right now is specification of the problem. So in integration, everything is about the domain. And once correctly given, software can employ different solvers to achieve the best results. Doesn't matter whether you are integrating something simple or you are integrating a differential equation, but you must be able to get your boundary conditions, and those are usually around domain issues. So you cannot outsource that. So no matter how powerful a software you have, you will still need to do the domain manually and find what is relevant domain to the problem, because whoever wrote the solver or the finite element code does not know the specific problem you are going to solve. You know the specific problem you are going to solve. It is your duty to specify boundary conditions, domains, and all the other things that you can sketch graphically before you go on to. At this level, getting the domain of an integral is just your best source to get into what engineers do all the time. You want to get your boundary conditions specified, and therefore you must understand how to get domains for integration or for differential equations or whatever else you do. There is no way around it, as far as I'm aware. If you have a way around it, good for you, but I don't know it. So I have about 20 questions that have just been loaded to the questions database. So I will just go through some of them, and wherever we get to, you can continue. Remember, as I told you before, in the list I'm giving you, the correct answer will be in A. So this, if you can recollect this equation, it's just like the multiply connected Stokes theorem, for multiple connected region. I will correct this later, but I'm thinking that the answer here actually ought to be D, not A, because this equation shows that the path integral borders a multiply connected region. That's why you have a summation of some integrals inside the region, which is included in the interior of the external region. The integral is independent of path. That is why the double integral vanishes, becomes 0. And then what you then have left is the equation of the internal integrals to the external integrals. The integrals are all taking the same sense, because that is how you negate the internal integrals, because ordinarily the internal integrals should be taken in the opposite sense. But by the time you take this equation, this part of it to the other side, the integrals are now taking the same sense. And the answer here is all of the others. This is an exception to the rule. I will correct this. The next one is the divergence of the function is a vector, and you want to find the divergence of the vector. Just coming to this, it should be clear that the divergence of a vector, last time I asked you, if a vector is of order 1, what's the divergence? The divergence is to take the gradient which promotes it by 1, and then take the trace of the gradient which demotes it by 2. So if you promote a first order thing by 1, you get 2 or second order. Then if you demote by 2, you get a 0th order, which is a scalar. So the answer should either be 5A or E. So that is it. So these three cannot be the answer. So if it's a vector, the divergence should be, and then just check that the answer here is 5, not 5K. Because if you take 5K, is that it shows that you do not understand that the divergence of the vector is supposed to be a scalar quantity and not a vector quantity. So that is that. The gradient of the vector function is a second order tensor. And if you look at the formula we have, it is 2I circle times I plus 3J circle times J minus I circle times J and so on. So this is correct answer here from the formula for gradient, which you have seen over and over again in some of the examples we have walked through. The next one, please comment on the chat room if you're having difficulty with any of these things. The next one, in plotting the octants of a sphere, radius A, centered at the origin, a parametric plot domain, x, y, the square root of a squared minus x squared minus y squared, x going from a minus a to 0, and y going from minus a to 0, represents the third top octant. Is the third octant. Please notice that you're going to find this in your tests and exams and self-tests. I'm using the mathematical way of specifying the domain. The first thing is the x, y, and z components in parametric form. The second thing is the is the range of the first variable and the range of the second variable. The first variable does not necessarily have to be X. It can be X and Z, it can be Y and Z, it can be X and Y, it can be R and phi, it can be R and Z, it can be rho and theta, it can be phi and theta, and so on. But if you are doing parametric work in 3 dimensions, then there will be 2 variables for 3 dimensions. If it is so that's just it. So that is, this one is the 3rd octant. And the best way to confirm this, if it is not obvious to you, plot it using mathematical or any other symbolic algebra tool you have. You will see that this is going to give you the curved surface of the 3rd top octant. So that is if you count from phi is equal to 0. 0 to 90 is the 1st octant, 90 to 180 is the 2nd octant, 180 to 270 the 3rd octant, and 270 back to 360 is the 4th octant. So if you do it that way, even though we represent angles from 0 to pi over 2, pi over 2 to pi, pi to 3 pi over 2, and 3 pi over 2 to 2 pi, that is the same thing. So those are the octants, and there are 4 on top, and there are 4 below. So you can check this out and you can try to understand. For those who have been practicing their mathematical, this becomes a piece of cake. You will move very fast. If you have been practicing, you will move very slowly if you have not been practicing. So that's just it. This again, unlike in this place, in this case, we parameterize using Cartesian. Here we are parameterizing using spherical polar coordinates. The same thing, but the parameterization is different. We're parameterizing here using spherical polar surface. The radius is constant. So rho is the radius of the curved surface here. And the theta goes from 0 to pi over 2. And phi goes from 3 pi over 2 to 2 pi. So that gives you the 4th top octant. That is the answer there. Again, plot this yourself using, you can plot it by hand if that's what you prefer, but I recommend using a software such as Mathematica or Maple or whatever you can use to plot. Mathematica is what I use. That's the easiest thing for me to use, and I recommend it. This is again the same thing. In plotting the octants of a sphere, radius A, centered at the origin, the spherical parametric plot is rho sine theta cos 0, rho sine theta sine 0, and p cos theta. Theta going from pi over 2 to pi, and rho going from 0 to a. It represents the flat surface between the bottom 1st and the bottom 4th octant. So that is a vertical plane. That's going to give you a vertical plane. After practicing this a lot, you could do this and understand it without the graphics. But it is because you are so used to the graphics and you understand how the graphics will come out. But without any practice of the graphics, I don't think you can get here that easily. So this is another question that you'll be facing. You may be facing. If you are not facing this, you are facing something similar. Because now I'm at question 37 out of the one that I'm sampling. So there are questions in between this that are going to be picked for you. We are here again, the same thing. In plotting the octants of a sphere, the radius A centered at origin, the parametric plot domain x0 minus the square root of a squared minus x squared minus y squared, with x going from 0 to a, y goes from 0 to a, represents the flat surface between the bottom and the 4th octant. I am suspecting something here. I'm suspecting that the domain here is wrong, but I will check that. Maybe I will take note of that and check. But you can check by, that is 6043. I'm thinking I've got an error here. So I'll check that. I think this should not be just A. So this is another question that looks like that. This particular case, question, I'll check 51 also. 651. Instead of explaining what it is in English, what we are expecting you to do here is to be able to translate from the Cartesian parameters to spherical polar parameters. That is what is being tested here. So you check this and you see which one of this does it correspond to. So again, the easiest way is to, if you are in doubt, just do a sketch and then you will see. This is another example of flat surface. Now we get to 1691. The position vector using parabolic cylindrical coordinates system. The cylindrical coordinate system, the parameters are xi, eta, and z. And this is the position vector coming from that. Because this is the position vector, you can get from this position vector their transformation equations. That shows that x is equal to xi eta, y is equal to half into xi squared minus eta squared, and z is equal to z, because it's a cylindrical coordinate, but not just the ordinary cylindrical polar, but it is the parabolic cylindrical coordinates. When you meet a question like this in your test or exam, notice that I'm just giving you more information. You do not need to know much about the parabolic cylindrical coordinates, except that this is its position vector. Whether you know it is parabolic cylindrical or not does not really help or hurt your ability to solve this problem. It's just good that you know what it is, just nice to know. So one of the following is not the coordinate surface. Now, coordinate surface, if you are using the parameters of the surface or of the coordinate system, the coordinate surface would be where any of these three parameters is equal to a constant. The constant can be 0, can be a number, can be pi over 2, can be 5, can be 10, can be. That is how you get the coordinate surfaces. Just like you get your coordinate surfaces in Cartesian, x is equal to 0 is a coordinate surface, y is equal to 0 is a coordinate surface, and z is equal to 0 is another coordinate surface, all at the origin. There are other coordinate surfaces, like for instance, x is equal to 5 is a coordinate surface, but it's not centered at the origin. So that is how it works. So this one that equates one coordinate to the other is not a coordinate surface. But these other ones, eta is equal to -5, z is equal to 3, and xi is equal to 0. Whether you write 0 is equal to xi or xi is equal to 0, it is for those who are not careful that this may confuse, because you should remember that xi is equal to 0 or 0 is equal to xi, exactly the same equation. So only this one is a coordinate surface. The others are not coordinate surfaces. So E is wrong, A is correct here. And the position vector here, blah, blah, blah. One of these is not a coordinate vector. One of these is not a coordinate vector. How do you get the coordinate vector? By differentiating the position vector. That always works. If you can have the position vector, you can get the coordinate vectors easily. So if you differentiate this here, that's what you get it. You'll see that when you differentiate this now, the only thing that you will not get among the things that are written is this one. Try the differentiation, you will find out that you will not get this quantity. And that is the reason why. So you can differentiate with respect to xi, differentiate with respect to what it is. If you differentiate with respect to eta, and then differentiate with respect to z, you will get other things, but you won't get this one. Then, when you are in an exam mode, this A and C may look alike, but look a little bit close. They are not. This is xi E1 plus eta E2. This is xi E2 plus eta E1. They look alike, but they are not the same. So, whereas this is a coordinate vector, this is a coordinate vector, this is a coordinate vector, but this isn't. So, and they look alike. So, looking alike is what means why you cannot easily guess the correct answer. You must, most likely, you need to do some work to get the correct answer. It's not, these things are not for the memorizer or grammar. So it's for somebody who has, those of you who have been doing your self-test, you know that you don't get things just by guessing. that easily. This is the same thing. Only one of this is only one of these is a surface tangent vector. So only one of this is a surface tangent vector. On the surface, eta is a constant. So you go here, you put eta to be a constant, so you now get a function of xi and z. You differentiate it with respect to xi, differentiate with respect to z. You get the surface tangent vectors. So you see which one, only one of these is a surface. You see that only one of them is a surface tangent vector. That's it. And then you also need to know that if you multiply a vector by a constant, it's still the same vector. So, okay, the position vector using parabolic cylindrical coordinate system, xi, eta, and z is given by this quantity, where E1, E2, and E3 are Cartesian basis vectors. This information is given just for completeness. It's not that you need it to solve the problem. On the surface, xi is equal to constant, the surface area vector. You know that surface area vector can be obtained by taking the cross product of two surface tangents. So this is the correct one by me is the A in this case. In some situations, I work it out. In some situations, I don't work it out. So it can come in several ways. So similarly here, this again, another surface area vector when the surface is eta is constant. Second to the last here, I think. The position vector using parabolic coordinate system is given by this. So on the surface, eta is equal to 1. One of these is a coordinate surface tangent vector. It's a tangent vector, and it is A in this case. And lastly, you have the position vector using parabolic coordinates, and then on the surface, eta is equal to 1. A vector normal to the surface is this one. This is a vector normal to the surface because this and this are tangent vectors. Taking the cross product of them will give you a vector normal to the surface. So basically, these are some of the things that I got from the latest additions to the database. I have what looks like 2 errors there, which I will correct, and I'll try and use that to do some quality assurance on my database. Okay, so what's time now? We are just 30 minutes into our time. I do not have more than this to give to you today. By next class, I should have gotten much more information as to how the testing will go. But for now, just continue piling up tests in your self-tests, and you will never be hurt. Even if you didn't get good grades, just make sure you continue improving, and that will help you. So we are not going to give you your worst grade. In fact, if you practice a lot of times, your worst grade might actually be thrown away. So it depends on how many practices you have. So how your self-testing will be used is going to depend on how many practices you have had. I'm going to also pause a little bit and see, after you have seen these examples, if there are questions that arise about how the self-testing is going and how the rest of the time will be. I'm reaching the conclusion that there is no point introducing a new topic at this point. I think you are already too overcharged because exam is so close that you are likely to be thinking more of how to pass than learning anything. So I'm going to call it quits at the number of topics we have done. Luckily for us, we did a number of weeks before the strike, and that helped us to at least have covered a reasonable amount of ground in this course. We didn't cover all we wanted to, but at least the grounds are quite significant. And I plead with you, go and practice your graphics, and you would have seen that you are paid. So, because if you practice some of these things, so hope you people are practicing your testing. So just go and continue practicing, and You should get good grades in this course if you practice, and I think you will not just get good grades, you know something. So that is, which is a goal. So that could be a basis for learning more stuff later on. So are you going to use mathematical during the exam? I'm still thinking about it. I'm thinking about it because, okay, thanks, Admin. I'm thinking about it. I want to I want to open it up as long as you do not communicate with other people. But I will, because I don't see why you cannot use mathematical in the exam. I don't see why not. Because even if you know mathematical, you will still have to know your domains. You cannot, mathematical will not tell you what the domains are. You have to do it yourself. So I don't really see any reason why not. Yes, you are using your personal exams for the exam. We have always been doing that. Yes, this course I've been teaching, because it's a teacher, let students use their. You need it. Are we using mathematical during the test? You could use mathematical during the test. In fact, I am toying with the idea that the test will be just, by the time I look at just go and do your self-test. I am beginning to wonder whether we need any test beyond your self-test. The other tests, the exam will be very much like your self-test. It's just that we are going to ensure that we watch you, that you not communicate with other people. That's why that will have, that's the only reason why that is going to have a higher weight than the other things. Every time you finish, every time you drop, we are monitoring every self-test you do. Every self-test you have done has been recorded. We are not going to record it, it's already recorded. The only thing is that different students will have different numbers of self-tests. We're going to have a simple rule to either choose top grade and then take the ones. So just make sure you attempt at least 4 self-tests, at least 4. Make sure at least 4 is done, because if you don't have up to 4, you are going to be in trouble, because unless you are doing very well. Because if you have a very weak grade, that's what we use for it. Do you get penalized when you exit self-test window to use another program? Well, I don't know. The admin may be able to tell you that, but I've not tried that to see. Okay, you go and use another window to go and get the expo. Okay. We should penalize you because you are not doing your work. So at least, when is the deadline for the self-test? Deadline for the self-test is the week of the end of the week of the end of the lecture-free week is the deadline. I think it's next week that is lecture-free. So I will check again. Yes, all your self-tests will count. Yes. When is it? Okay, I will check. I have the calendar. I will check. I don't want to talk off record. I will check the calendar. I'll check the calendar. But just continue self-testing. That's the reason why I populate with so many questions, is that you can just continue going on and on. So that's why I've just added 120 questions this weekend, from last week to now. So that is adding to another 400 that we had before. Well, I don't have that answer. I will check and tell you. I don't have that answer. Okay, shall we say that by end of, since we are finishing, we are not going to do more. What is important right now is that I think what's important right now is that you get your self-test done at the end of next week. So at the end of next week, we will stop the portal for the self-test. Or even if you don't stop the portal, it will stop counting after the end of next week. How many objectives are you going to answer in the exam? I think we usually ask me to do 50 in the exam. Or during the casual self-test, you are doing 30. So maybe do 50 in the exam. But the decision hasn't been taken. But that doesn't, what does that, that doesn't, have we come to the end of the course? Yes, we have come to the end of the course. You will find the duration when you are at the test. When you are at the exam, you will find the duration. Please, do the formal test we have done? Yes, they can't. I'll answer that question. Do you have more chapters of your textbook available? We only have chapter 1. Yes, we have other chapters. I think they are on this website. The admin can give you access to it. There are 7 chapters, I think. So the admin can give you access to it. Is there? Okay, okay. But I want you to finish. I can, please finish your self-test at the end of next week. Self-test at the end of next week. So that you can have time to do other things. Do at least 4. The more you do, the better for you. It is going beyond, it is at the end of next week. Why are you asking for, what is the point, Emmanuel? Why do you want it to be extended to be beyond? If somebody has attempted 10 times before the strike, is there any need to well, it is a matter of choice. If you got good enough grades, you may not, but the disadvantage is that you will not have been able to test with, because you know the database has increased. Database has increased. You are getting a better preparation for the finals. Well, I will still be available on Wednesday for Q&A. So there are things to, I continue populating the database. If there are new sets of questions, that I think I can show you, I'll show you on Wednesday. But I am still populating the database with more questions, and that takes a lot of my time. That's what I did through the weekend, and I will do more. So no, I can't tell you. What I will tell you, Adeliji, about the grading is that we will not, if you have done more than 4, your bad grades will be removed. Your worst grades will not be used. And we may remove your best and worst and take the middle grades. So, okay, so I think that's it for today. And wish you all the best for the rest of your day. Goodbye.